Developing quadratic formula. Developing the quadratic formula is a natural culmination in the quest to solve quadratic equations. We first solved the quadratic equation by factoring in using the zero principle. The weakness with this method is that not all quadratic equations can be factored, so we needed a better method, especially one that would always work. Mathematicians developed completing the square. It always works, but can be more difficult to use than we would like. To solve the difficulty issue, why not solve the general quadratic and just use a formula? Developing the quadratic formula. We start with the general quadratic equation and the quadratic formula. The if-then statement below shows the quadratic formula and the general quadratic equation. So if ax squared plus bx plus c equals 0, then we know for sure that x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. So we'll have our x as long as we know what a, b, and c are, and we can find the a, b, and c from the general quadratic equation. We will now show how this formula is developed. Notice that the general quadratic equation is set equal to 0. Developing quadratic formula. Ax squared plus bx plus c equals 0. And we can divide both sides by a. And we do that so that we can get rid of the numerical coefficient on the x squared term. So we get x squared plus b over ax plus c over a equals 0. Now watch each step and decide, can you see what we did and how it was done? The algebra is a little general, has some fractions in it, but it's easy to understand if you have a pretty good working knowledge of algebra. So now let's see, what do we want to do next when we were completing the square? That's right, get rid of the c over a. So we're going to subtract c over a from both sides. And we get x squared plus b over ax plus, and I left a little blank there, equals a negative c over a. So it did disappear on the left and reappeared on the right as a negative by subtracting it from both sides. Now what do we want to do next? In completing the square, we wanted to know what we could put in the blank that would make that a perfect square trinomial. And then whatever that was, we're going to add it onto the right-hand side. Now the way we did that was we took half the middle term, b over a, that'd be b over 2a, and we square b over 2a. And we get b squared over 4a squared. And we have to add that onto both sides to keep our equation balanced. Now if we look at this, we want to factor the left-hand side down to something times itself. And on the right-hand side, we want to be able to find a common denominator between those two fractions. So let's do both of those, and then we'll talk about them. So we factored the left into x plus b over 2a times the quantity x plus b over 2a. And on the right, we found a common denominator of 4a squared by multiplying the numerator and denominator by 4a. So now we'll rewrite the left-hand side as a quantity squared, and we'll add the two fractions together on the right, putting the positive one first. So we get the quantity x plus b over 2a squared equals b squared minus 4ac all over 4a squared. Now look at what we did. We added the ones on the right. We put the b squared first just so it's kind of nicer to have that b squared minus 4ac on top rather than the other way around. And we put them over the results over the common denominator. On the left, we just rewrote what was in there. We had something times itself, so you could write it as a squared. Now we're going to take, the square root of both sides. Okay, now when we take the square root of the left-hand side, the square root is going to get rid of the square. In the right-hand side, we can't take the square root of the numerator, but in this case, the denominator is a perfect square. so we can take the square root of 4a squared. And we get x plus b over 2a on the left. Square root, got rid of the squared. And on the right, we couldn't take the square root of the numerator, but we could of the denominator, so we did that. Now if you look, we only have one more thing by the x. So all we got to do now is subtract b over 2a from both sides. So the x now is by itself, and we have a negative b over 2a plus the square root of b squared minus 4ac all over 2a. Now fortunately, both these have a common denominator, so all we have to do is combine their numerators. So we get x equals b squared plus or minus the square root of b squared minus 4ac all over 2a, and that is the quadratic formula. So that's pretty nice how we finally solved the general quadratic, so now we can just use the formula. And all we need to know is the a, b, and c, and be a little careful with our order of operations in solving that quadratic formula. I'd like to just look up at what happened between row 3 and row 4. Going from row 3, which is a single equation, to row 4, which is a single equation, the thing on the left I'm more interested in, we factored that. And so if you look at those factors, are those the factors of that? Are the fourth row factors, will they multiply out and give you the third row on the left? So I'm going to kind of review that. So checking the factoring going from row 3 to row 4, we're going to take that x plus b over 2a and multiply it times x plus b over 2a. And so this is in row 4, and we're hoping to get the trinomial in row 3. So let's see, we just use the distributive property. X times x is x squared. X times b over 2a is x times b over 2a. Plus b over 2a times x is b over 2a plus x. And then last is b over 2a times b over 2a is b squared over 4a squared. Now in the next step, we factor out the x out of the middle two terms so we can combine their numerical coefficients. So then we can add that b over 2a plus b over 2a, and we get 2b over 2a. Then in the last row, we cancel the 2's, so we get x squared plus b over ax equals b squared over 4a squared. And if you look and go back from row 4 to 3, that's exactly what we're supposed to get. So we have developed a quadratic formula. I think this is a very interesting proof because a quadratic formula is kind of complicated and you wonder where did it come from. This is where it came from. And all the algebra is straightforward. We had to deal with a little fractional algebra, and we also had to deal with some factoring, but it works out real nice.